Welcome to Hacking Your ADHD. I'm your host, William Kerb, and I have ADHD. On this podcast, I dig into the tools, tactics, and best practices to help you work with your ADHD brain. Hey team, we're diving right back into the world of ADHD research, continuing on from what we were talking about a few episodes back. So for this episode, we're going to be more focused on what goes into making ADHD research more reliable. I go in depth into what you can expect to find when reading a study, and then also what things to look out for when trying to determine what's going on in those studies. We'll discuss how to navigate the sometimes confusing world of what a peer-reviewed journal is, why sample sizes matter, and what to watch out for when it comes to conflicts of interest. I mean, everyone's interested in how ADHD research is funded, right? This piece was also initially going to cover a bunch of stuff about misinformation, but with how much ended up going into everything else, I'm saving that for next week. If you'd like to follow along on the show notes page, you can find that at hackingyyouradhd.com/198. All right, keep on listening to find out about the insides of ADHD research. In the last episode in this series, we discussed the kinds of ADHD research there is. But I think we should also work on understanding what makes good research, because not all research is created equal. When we look into how to evaluate research, often the first thing we hear is that we need to look for peer-reviewed journals. Peer review means that other experts in the field, who weren't involved in that particular study, have evaluated it before it was published. They check whether the research methods are sound, whether the data supports the conclusions, and if the study adds something valuable to the field. As a casual reader, ensuring research is peer-reviewed will probably be our most critical step, because we're not equipped to make those judgments nearly as well as someone within the field. And we'll talk more about what makes good research in a minute. But before we go into that discussion of what makes good research, I want to play with this idea of directing you to peer-reviewed journals to get your information about ADHD, because I don't actually think that's particularly good advice. This isn't to say that peer-reviewed journals aren't the best source of ADHD research. It's just that I don't think it's wise to direct someone to peer-reviewed journals as their first source of information. It's like telling someone the best way to learn to fly a helicopter is by reading the manual. I mean, that's probably got the best information about how that helicopter works, but it isn't going to help you with the real-world intricacies of how flying a helicopter really works. These studies are often hard to read. Researchers often use scientific terminology, abbreviations, and statistical terms that can be hard to understand for someone without a background in the field. It can be incredibly easy to misinterpret what a study's authors are trying to talk about if you aren't familiar enough with the underlying research and terminology. An easy example of this comes from the term statistical significance, which means the results are unlikely to have occurred by chance. Someone unfamiliar with that terminology could easily misinterpret that language to mean that the results are large or meaningful in a practical sense. Statistical significance means that this is worth looking at because the results are likely not just happenstance. But it doesn't mean that there is necessarily a significant practical effect. For example, let's say researchers are looking at an intervention that can reduce impulsivity, and they find that their results are statistically significant. However, the actual difference the intervention group and the control group might be very small. Say the intervention reduces impulsive behavior by 5%. So we can say, yeah, this does have an effect, but not in a meaningful way in a real-world scenario. And this is what makes this lexicographical understanding so important. These words have specific meanings. If you don't have the background in what those words mean, it is incredibly easy to misinterpret those results. And I do read a fair number of studies from peer-reviewed journals while working on the more science-based episodes. But I think the idea of sending you off to read those studies is just kind of garbage advice for someone just doing casual reading of the research. It's not because I don't think you're capable, it's just often more work than it's worth. I've taken classes on how to read research studies, and combing through all that information is still a daunting task. Now, with that said, I still think it's important to understand what makes good research. When we're out and about on the internet, we're going to run into people citing papers and various studies, and if we want to be able to do some of our own due diligence on whether or not that information is credible, we need to know what to look for. While it's always great when a creator comes with receipts for their claims, we also need to understand that not all research is created equal, and not all research is done in good faith. Now, if you're like me and you were a science fair kid, you might be fairly familiar with how a research paper is structured. But if not, let's go over that real quick. Firstly, after researchers do their studies, they submit those results to a peer-reviewed journal in the form of a paper. That is, if they're doing this route. These journals often have fairly strict guidelines on how a paper is formatted, so that's why we see this kind of structure. They put it together in this way to ensure that the research is systematic, reproducible, and valid. Papers always start with an introduction that outlines the rationale behind the study. The introduction explains why the research is necessary, will review relevant literature, and highlight gaps in current knowledge. It will also highlight specific questions the study seeks to answer or the hypothesis being tested. Next, you have the methods section that details how the study was conducted. It will include the number of participants, the study design, the interventions being tested, how relevant outcomes are measured, and what kind of statistical analysis is being used to analyze that data. Next, we have the results, and that's basically what you'd expect. This is where all the data from the study is presented, often with charts and graphs. You'll get to see the statistical significance and the effect size here, and we often see data on whether participants adhered to the treatment protocol, or how many did and how many didn't. We then get to the discussion section where researchers discuss the meaning of their findings in the context of previous research. They explain whether the intervention was effective, the practical significance of the results, and any broader implications. Also importantly in this section, researchers should be mentioning limitations of the study, such as a small sample size, short duration, or potential biases. And there's often suggestions for future research included here as well, usually based on those limitations that they had. Finally, we get to the conclusion where the researchers summarize their key findings and the implications. It basically takes everything above and gives you a "what does this all mean?" And then the paper will also include a reference section and any supplementary information that might be needed in the context of the paper. Additionally, a paper is going to include an abstract, which is just a concise summary of the research study or paper. It's there to provide readers with a quick overview of the key aspects of the research, helping them decide whether the full paper is relevant to their interest or need. This is typically the part of paper you'll find on something like a Google search, or what someone will link to when they're citing a paper. Often, journals will let you read the abstract of a paper for free, but then paywall off the rest of the paper. Alright, so that's the structure. Now, when we're looking to assess research, we're mostly going to be focused on the methods section because we want to know if a study was actually measuring what they said they were measuring. But we'll get into some other specifics as well. As I mentioned earlier, the first thing we want to look at is if a research paper was peer-reviewed. Unfortunately, that's not always the easiest step. While some journals will explicitly mention whether the article has undergone the peer review process, more often than not you have to look at the journal itself to determine their peer review policy. Peer-reviewed journals are often recognized by their titles. So, for example, well-known peer-reviewed journals in various fields include the Lancet for Medical, Nature for Scientific, and the Journal of Attention Disorders for ADHD research. If you haven't heard of a particular journal and you see a study in it, be sure to Google that journal first and see what the general field feels about that journal. They usually have pretty strong opinions about what's good and bad journals. Now, in these terms, it becomes more important to understand where non-peer-reviewed work usually comes from. Of course, we have things like magazines, newspapers, blogs, and non-academic books, and that's fine. So those are often meant to be informative or opinion-driven. But typically, you won't see them undergoing the same rigorous scientific scrutiny. What's more likely to get mistaken for peer-reviewed work are things like preprints, where researchers share their findings before the peer review process, or conference papers and posters where researchers are showing off the early stages of their research. You also have companies and organizations often releasing reports, white papers, and studies that are not peer-reviewed but are used for their own promotions. Even within peer-reviewed journals, editorials, opinion pieces, and letters to the editor are often not actually peer-reviewed themselves. Instead, they reflect the opinions and interpretations of the author of that, rather than the original research. Non-peer-reviewed sources are often faster to publish and reach a broader audience. They provide value in terms of opinion, accessibility, and preliminary research, but they should generally be interpreted with more caution. So while these non-peer-reviewed sources can have value, it's something that as a layman reader, we should be on the watch for. Alright, now let's get into the actual meat and potatoes of this episode, and get into what we're looking at when we're looking at these research papers. The easiest thing to start with is sample size, which refers to the number of participants that were involved in the study. As a general rule, larger sample sizes tend to produce more reliable results. When a study involves hundreds or even thousands of participants, we can often be more confident that the findings are representative of the broader population. But of course, bigger is not always better. A larger sample size can make it easier to find statistical significance. But, as we mentioned earlier, statistical significance isn't the same as practical or clinical significance. One of the ways this can happen is through a practice called p-hacking, which refers to the practice of manipulating data or selectively reporting results in order to achieve that statistical significance. I don't want to dive too far into the weeds here, but a p-value is a statistical measure that helps researchers determine whether the results of an experiment or study are significant or if they occurred by chance. The threshold is commonly around 0.05, meaning that there is less than a 5% chance that the results occurred by random chance. Researchers can manipulate the value of their data through the kinds of analysis they are running by cherry-picking their data, by ending their data collection early, and by examining multiple subgroups. With a large sample, it can be sometimes easier to find that statistical significance simply because there is more data that can be manipulated in this way. Also, I just want to mention again, this is something that is more important for someone who is doing the peer review process and not something for a layman to be overly worried about. And I also want to say this isn't something that will always be the case with large studies. But it is always something I consider when I see a study with a surprisingly large sample size. Next up, we also want to consider what kind of study we're looking at. In clinical research, randomized controlled trials, or RCTs, are considered the gold standard. In an RCT, participants are randomly assigned to either the treatment group or control group, and the outcomes are then compared. Another way that researchers can reduce bias in the results is by blinding either the researchers or participants, or both, meaning that they don't know who's getting the real treatment or the placebo. Of course, not everything studied can be done through an RCT, either through limitations of funding or in the scope of what they're looking for. For example, researchers might choose to run an observational study where the researchers follow a group of children diagnosed with ADHD and a control group of children without ADHD over several years, observing their academic process without introducing any treatment or changes to their environment. Because the researchers are not manipulating any variables, such as introducing a new treatment or intervention, randomization doesn't make sense. But the point here really is that you have other kinds of studies than an RCT that provide valuable research, even though that RCT would be the gold standard for something that's looking for a particular intervention. Additionally, we also might see cohort studies where researchers follow a group of people over time to examine how certain factors, like treatment or environmental exposure, affects outcomes. Or individual case studies where there is an in-depth, detailed examination of an individual or small group, focusing on their unique characteristics, treatments, and outcomes. Then there are also meta-analysis and systematic reviews, which don't collect new data, but instead analyze the results of multiple studies on a particular topic. A meta-analysis statistically combines the findings of several studies, while a systematic review synthesizes the evidence from multiple sources. So while the RCT is the gold standard for doing clinical research, there are also tons of other ways that ADHD research is being explored. These other types of studies can provide valuable insights that are not possible with the RCTs. Alright, next up we want to work on understanding the methodology, how the study was conducted. Methodology includes how participants were selected, how the data was collected, and how the results were analyzed. For example, was the study using objective measures like brain scans or behavioral assessments, or was it relying on self-reports and questionnaires, which might introduce bias? Again, peer review here is especially important because, as casual readers, we often lack the knowledge to distinguish between good and bad methodology. That said, there are things that we can absolutely be on the lookout for. For example, earlier I mentioned how large sample sizes aren't always better, with one reason being that often with a really large sample sizes, researchers rely on survey data, which isn't always an especially objective measure. A better designed study might combine these ratings with more objective measures like neuropsychological tests or performance-based tasks, but that of course costs money, so it isn't super likely with a really, really large study. In contrast, a small study with only 20 or 30 participants might not provide enough data to make a strong conclusion. The sweet spot is going to depend heavily on the study design and their methods. Okay, let's move on and hit one of the biggest elephants in the room for ADHD research, which is funding and conflicts of interest. ADHD research is funded through a mix of government, pharmaceutical, nonprofit, and public sources. In the US, government agencies like the National Institute of Health, NIH, provide substantial funding for basic and clinical research, while pharmaceutical companies focus heavily on the medication trials. And it is that pharmaceutical industry funding that is often drawing a lot of this criticism, since they often have a vested interest in the results of the studies that they are funding. While industry-funded research isn't automatically bad, it can introduce potential bias. Researchers might feel pressured, whether consciously or unconsciously, to produce results that are favorable to the company funding the study. And I'm going to slow down here because I feel like this is one of those places that I see the most criticism about ADHD research. I've absolutely heard people say that ADHD was made up by Big Pharma to sell ADHD meds. And unfortunately, I can absolutely see how someone could come up with the idea because there are plenty of examples of these companies putting profits over people. So it makes sense that because these companies make a lot of money selling ADHD drugs, that maybe they don't have the broader ADHD community's best interests in mind when doing that ADHD research. This again is a place where peer-reviewed journals are super important. Reputable journals require authors to be transparent about where their funding comes from and any relationships they may have with companies or organizations. That transparency here is crucial as it helps you gauge whether the results could have been influenced by those external factors. It's also important that we acknowledge that a lot of the research that these companies do is government mandated. In the US, the Food and Drug Administration mandates that before they approve any of these medications, that the companies conduct the research that proves that these medications are safe and effective. I'm not going to try and say that this system is perfect, or even that it's above accusations of corruption. Now, with that said, I think it's also important that we understand that funding for ADHD research overwhelmingly comes from the federal government, and that when you receive funding from government, the government just doesn't have that same level of motivational bias about what ADHD research ends up saying. So there's a lot less bias in here than a lot of people initially said. Now, with that said, one of the other things we can keep an eye out for here is whether or not a study is part of a consistent body of evidence or it's just a single result. Replication is a cornerstone of scientific research. One study might produce promising results, but if those results can't be replicated in other studies, we can't really trust them. This doesn't mean that we completely disregard those results. It just means that we want to see more research. It's about looking at the broader context of what is already in the ADHD library of research and understanding that the most reliable findings are those that have been repeated and confirmed by multiple research teams in different settings. If we extrapolate this out with this topic of where the ADHD funding comes from, we can see how that reduces a lot of the bias if there are a number of studies that are showing these same results, even if we are worried about where the funding is coming from. Okay, well, multiple groups said this is true. Okay, that's a lot more believable. All right. Finally, we want to consider limitations within a study. Good research doesn't pretend to be perfect. We want to look for studies that openly discuss their limitations. Were there issues with the sample size, with a study conducted in a specific population that might not apply to everyone? Were there potential biases that the researchers couldn't fully eliminate? One thing you'll see in some online discourse when talking about science is the creators going after a study because it didn't look at one particular variable or another. And often, if you presented that same argument to the same researchers in the study, they would wholeheartedly agree with the criticism. A single research study can't cover everything, and so this is why we need to look at the broader spectrum of research instead of just an individual study. Acknowledging limitations shows that the researchers are being transparent and cautious about interpreting their results. It also helps readers understand how to apply the findings appropriately and not overgeneralize from a single study. All right. I'm going to wrap things up here because, well, this has ended up being a much longer piece than I was expecting. It's like when you're telling a story and you just keep having to add more and more context, except I get to go back and add things in. It really makes everything flow so much better when I don't have to keep interrupting myself going, well, I should also tell you about. Except in this case, I didn't get to any of what I wrote about misinformation in regards to research because that's now an entire 15-minute episode as well. And so, we'll be getting into that next week. Thanks for sticking with me all the way to the end. But before you go, let's do a quick rundown of today's top tips. 1. The first step in examining a research paper's credibility is to ensure that it's peer-reviewed. The peer-reviewed process will cover many of the steps that we discussed in this episode. While there is some value in non-peer-reviewed work, it's important that we approach that kind of stuff with a skeptical lens. 2. However, with that first tip, we should also know that we shouldn't view peer-reviewed journals as a beginner's source. They are written with the expectation of other experts as the intended audience, and without the prerequisite knowledge, it can be easy to misinterpret what's being said. 3. One of the largest concerns about ADHD research comes from worries that pharmaceutical money will introduce bias into many of the studies. However, most research is actually funded through government grants, and the peer review process is designed to help identify conflicts of interest and eliminate any bias that may be present. Alright, that's it. Thanks for listening. I'd love to hear what you thought of this episode. Feel free to connect with me over at hackingYourADHD.com/contact. If you'd like links or to read this episode's transcript, you can go to the show notes page at hackingYourADHD.com/198. And now for your moment of dad. Why did the show about planes never take off? Because it had a lousy pilot.